Hello guys, this is Yagi Narayan Shukla, and in this short video I will discuss with you about work done. So what is work done? In general, we think that the work done is something that we do, right? And we say ki today I did a lot of work, today I am exhausted because of a lot of studied, I did a hard work. So this is in general our language about the work done. But in physics, work done is certain different. So we will come to know today what exactly work done is. So we will take a simple example to understand this concept. So work done, suppose let us take an example here. This is a block and this block is kept in a smooth surface. Smooth surface. Let's say I am applying here force of 10 Newton. This is the magnitude I am taking here just to understand the concept of work. I have applied a force of 10 Newton and this 10 Newton force having constant in magnitude with reference to time means this is a constant force. This force is not varying with respect to time in this particular case. Because of this force, let's say at t equals to 0, the position of this block is this and it is now currently it is in rest. So what effect of this force will be on this block? See, we all know that what force can do. So force can move a body which is in rest, or force can change the velocity of a body. Force can deform a body. It can change the shape and size of a body. Force can change the direction of a body. So here the force is basically moving the body from this position to this position. So for this motion the body will take certain time. Let's say it is taking 5 seconds. Okay. So after 5 seconds you have seen the block will have moved from this position to this position. So the displacement between these two positions, it is the shortest path, or the displacement is what? Let's say it is 10 meter. I am taking just a random figure so that we can understand the concept of work done mathematically. So the force is in this direction, okay, horizontal and in the positive x direction, and the displacement is also in the positive x direction. Okay, so work done by force F equals to 10 Newton will be magnitude of force, means the value of force, we can say magnitude of force, multiplied by displacement. This will be the work done by this force. It is very simple example that I am taking here. The force is of 10 Newton and displacement is of 10 again meter. This is in Newton, this is meter, so it will be Newton meter and it will becomes 100 Newton meter, and we will say this Newton meter as joule, the 100 joule. Okay, so this is the work done by this force. So what we concluded here, what we will conclude here, work is done by a force, So this is the force and this is the displacement. So force will, if we are applying force on certain body, because of the result of that force will be seen as displacement. So this force is displacing this object of 10 meter. So we have to understand the role of direction, here. So here the force direction is this, F direction is this, and the displacement direction is also the same. So the angle between force and, let's say this is D, displacement. So the angle between force and displacement is 0. So angle between force and displacement F and D is 0. Okay. So in this case, when the angle between these two forces is 0 degree, so we can directly multiply the force and displacement, or we can say that if the direction of force applied and the direction of displacement is same, then the magnitude of the work done will be this. Okay, this is very simple example that we have understood. Let's say कि I am adding one more concept here. Let's say कि this block have the mass of 5 kilogram. Okay, and due to this mass, a weight will act in the vertically downward direction, and the magnitude of weight will be mass into acceleration due to gravity m into g, and mass is what, 5 kg, and acceleration due to gravity, let's say it is 10 meter per second square. So the value of weight here will be 50 newton, the weight. So in which direction this weight is acting? Vertically downward direction, and its magnitude is 50 newton. Let's say. Now again we are applying 10 newton force, and this block is moving in horizontal direction, and after 5 seconds, let's say this block has moved from this point to this point. Okay, it is very simple example that I am taking here. Now if I ask you work done by weight, 50 newton is, because it is also force. If this 10 newton can do work, so this 15 newton can also do work. So work done by weight of 50 newton, what will the magnitude of the work done? So you will say कि 50 newton into, this is force, and displacement is 10 meter, and the answer will be 500 newton meter. So this is the wrong answer. What I have told you, कि the direction of force and direction of displacement must be same to apply this formula. Okay, so here the force direction is this 50 newton, okay, and displacement direction is this 10 meter, and the direction between force and displacement here is the angle between force and displacement here is 90 degree, and whenever a force and displacement has perpendicular direction, so the work done by that particular force is 0. So here work done by weight is 0. So what is the general formula that we can apply to get any kind of work done for any kind of force? So obviously we are taking here a constant magnitude force. So let's say a general example, and I am modifying this question again, and I am applying a force of again 10 newton, but I will apply this force at an angle 30 degrees, let's say 30 degree, with horizontal of same of 10 newton magnitude. Now here see very carefully, the work done by force 10 newton will not be 10 into 10 force into displacement. There must be a generalized formula. So what I will do, I will change something. Okay, see carefully, you will get the concept. This 10 newton has two components. One component is along the displacement, and another component is perpendicular to the displacement. This along the displacement component will be 10 cos 30. I will get this value from the geometry, simple geometry, Pythagorean, means right angle triangle, by drawing the right angle triangle, and 10 sin 30 will be this angle. Okay, so this sin 30 degree will not do any kind of work in this case, because the direction of displacement is this, and the component of 10 newton, which is 10 cos theta 30, is acting in this direction. So the force will be 10 cos 30, and displacement will be 10 meter, because in the direction of force displacement is written here. Or we can say in the direction of displacement there must be a force here. We cannot write different direction of displacement and force. So here the value will be 100 cos 30 will be 1 by 2, cos 30 will be root 3 divided by 2, root 3 divided by 2, so it will be 50 root 3 Newton meter. So this will be the answer. So this is a simple examples that I have took to give you a brief introduction about the work done, and this is my video.